Okay, so what were the three Zeno's paradoxes?
Well, this one was actually the first one sort of related to this one here. So if we go back to the original wall here and you're trying to reach it, this paradox says that you can't even start walking toward the wall because in order to reach the wall, first you have to take a step, and to take a step you have to take half a step. To take half a step you have to take a quarter of a step, and so on. And you have to take infinitely small steps. But even if you go down to infinity, you can't ever start because this is just going to get infinitely small. So if you take infinitely small steps, then you're just not going to get anywhere.
Okay, yeah, all right. So the book talked about a paradox that says you can never actually move.
Yeah.
Do you believe that's true?
No.
Why not?
Well, we can move.
Yeah. Oh yeah? Prove it to me. But do it on camera. Prove on camera that you know how to move.
So like just.
Okay, yeah. All right. So.
We can move, but I guess in theory, in reality, the paradox doesn't work because we can actually like take steps larger than an infinitely small step.
Okay.
Well, but I guess in theory it could work if you have to take.
Yeah, it's pretty confusing, right? Like, I'm pretty sure we know how to move.
Yeah.
But this paradox is a little tricky. All right, but that's fine. That's a good one. What was the difference, Zeno's paradox?
Well, this one I think was involving Achilles, a runner, and then a tortoise.
Okay.
So this one says.
I'll get the wall out of the way for this. You want to draw on the tortoise?
Let's see. So if you have like a tortoise, and if you give the tortoise a head start, Achilles will never be able to catch up to the tortoise because every time Achilles runs the distance to the tortoise, even though the tortoise is moving slower, he'll move some distance, and then Achilles will move that, and then he'll move another small distance, and then Achilles will move that, and then he'll move another smaller distance in that time, and he'll just end up converging. Oh, they won't converge, but like the tortoise will just end up moving smaller and smaller distances, but Achilles will never actually catch up.
Okay. What do you think about this? Do you think this is true?
No, I don't, because they actually use like sort of math to prove it.
Okay.
So, say Achilles can run 10 meters per second if he's a really good runner,
right.
And the tortoise can move 1 meter per second.
Mm-hmm.
And the tortoise gets a 10-meter head start.
Yeah.
So this is 10 meters from here to here. So first, Achilles runs this in 1 second. But in that time, so we have 1 second so far. Then that time, tortoise moves a meter. Achilles can run that in 0.1 seconds. 0.1 seconds, the tortoise will move a tenth of a meter. Achilles runs that in 0.01 seconds. Tortoise moves a hundredth of a meter. Achilles runs that in 0.001 seconds, and so on. So eventually you're going to get this sequence, which adds up to 1.11111 repeating, which is 10/9 seconds, or 1 1/9.
Interesting. So, in this situation, you can actually explore the math all the way through, and you can find the exact time that Achilles catches up to the tortoise.
Yeah, and there's one other way you could prove it, I guess. So, you can write an equation for the distance Achilles runs for a certain amount of time. So since he runs 10 meters per second, the distance is going to be 10 times the amount of time, amount of seconds, I guess.
Yep.
And then so this has to equal, since the tortoise can only run 1 meter per second, it's just t, but it's plus 10 because he got a head start.
Okay.
So subtract t from both sides, you get 9t equals 10, and then you just divide by 9.
Oh, nice. Okay, so there actually were two ways
Yeah.
to get it. One was involving infinity somehow, and then one
Yeah.
was just some nice equations here.
Yeah.
Cool. Well, why don't we stop there? I know you said there
Okay.
were three, but we can stop here. What did you think about this first chapter?
I thought it was a good introduction to like the concept of infinity and gave examples of infinity, useful and confusing.
Did you find those examples useful?
Well, the pizza proof was a good way to prove the area of a circle is pi r squared.
Yeah, great. All right, cool. Hey, good work. I was hoping you would like this book or this chapter of the book. I mean, and it turns out it was pretty neat. Good job, hun.